Today's video is brought to you by Nihon Denki and Noise Laboratory. Hello everyone, today's video is a collab with Nihon Denki and Noise Laboratory. I'm currently at the Noises Experimenting Laboratory in Funabashi City, Chiba. At this laboratory, we'll be conducting static electricity experiments. Alright, let's go take a look at what it's like inside. Here is a shielded room where we will be carrying out our experiments today. This is the discharge testing device. This is a product of NoiseKen, and next to it is the discharge gun. If you pull the trigger, it emits static electricity. We'll put this next to an object and observe various reactions depending on the object. This right here is the desk that will be our testing environment. As you can probably tell, this is actually a wooden desk. The reason for this is that we want to insulate it from the ground plane on the floor. We want this wooden desk to be our wall between electricity and the floor. Take a look at the top of the desk. As you can see, it is covered by metal. This is called the lateral coupling layered plane, and it is to mock the behavior of a steel desk. This desk is used to create an environment in which one would get shocked when coming in contact with the top of the desk. To begin, we'll connect the discharge cable. Look here, you can see that there is a screw sticking out from the table. This is where we'll attach the cable. If you look at the cable, it says 470K ohms. This number is quite important for this kind of experiment. If it says 0 ohms, the speed of the discharge would be too fast. By putting a resistance of 470K ohms, we can slow down the speed of the discharge significantly. Via the discharge cable, connect the lateral coupling surface and the ground plane. This ground plane on the floor actually has multiple holes. Using one of the holes, you can screw down the discharge cable. Now, place the insulation sheet on the desk. Now that the sheet is laid down, you can take an object, like a smartphone, and apply your discharge gun. This will be how we'll conduct our experiments today. Next, we'll place a vertical coupling plate on the desk. There is also a type of testing where you apply the discharge gun directly to the vertical coupling plate. That is to observe the effects on nearby objects around the plate when the discharge gun is applied to the plate. This way, you can see the effects on those objects from indirect static electricity. Once attached to the board, attach it to the ground plate. Here comes our most important device of the day. This device is one that discharges battery and one that will connect as well. This is currently only at 30 kilovolts, but the strength is already obvious. Here, I have lined up some items we'll be using for experiments. This is Let's Note, a simple laptop. I believe the outer surface is made of magnesium. Perhaps it'll be easier to discharge. For today, we'll apply the discharge gun right at the laptop. I've also brought a custom PC. I'm sure there are some of you who have built their own PC. Oftentimes, getting shocked by a PC is something people worry about. I hope today's experiments will clear up some of those concerns. I also brought an SD card and a USB drive. And lastly, I brought a smartphone as well. This is one of the objects we will use for the experiment. This is actually my old iPhone that I used before. It's quite old, so worst case if it breaks, it's not a big deal. We'll also use this watch because why not? I'm sure a digital watch won't be affected anyways. So I brought this digital watch to see whether or not that's true. The first contender of our experiment today is this laptop right here. We'll play a video while applying the discharge gun. Because, that sounds more interesting and appealing. You can adjust the voltage and other options here. Take a look here, it says 8 kilovolts. According to what I heard, 8 kilovolts is the standard for air discharge, which is done without physically touching. So we'll set it at 8 kilovolts for today. Can't quite see the discharge. Oh, it is. It's just really weak though. So I just tried it with 8 kilovolts and it seems like it's a bit too weak. You bring the tip close to the object, just like this, but to be honest, I could barely see anything. On the device, the maximum available voltage is written here. What was the max for this again? 30 kilovolts is the max. Do you ever use 30 kilovolts for an experiment like this one? No, we barely use voltage that high. Okay, I see. Okay then, let's set it at 30 kilovolts for today. We'll use 30 kilovolts, the maximum voltage level for this device. Ooh, you can definitely feel this one. Can you see all this? We're currently discharging at 30 kilovolts. Listen to that electric sound. It's so strong that I'm honestly a little scared to have my hands so close to it. Oh, I just felt the shock from the desk. Well, it's being discharged, but the screen is clearly working fine. Even at 30 kilovolts, no malfunction seems to be occurring. I gotta say, it's a well-built laptop made in Japan. Take a look at the port sections on the side. There's a lightning port, USB port, HDMI port, there's an earphone jack. I have a feeling that these ports are vulnerable to shocks, and there's only one way to find out. I'll be careful not to touch the desk this time, so I won't get shocked like I did earlier. Sorry, it was actually not fully on the insulation sheet, so let me do it again. Make sure to use a static eliminating brush as well. This is amazing. Let's see if anything happened. Oh, I'm surprised. It's still working perfectly fine. I believe ports like these with no covers are vulnerable to static electricity in general. But it's not affected at all. We just applied a discharge gun right at the USB port. We'll see if there's any impact on its functionalities after that. Surely, after all of that, they really shouldn't function. Let me insert this SD card and see what happens. It seems that nothing's being detected. Oh, wait, it's being detected. I just inserted an SD card right where it was discharged, but it seems like there's no problem so far. Checking the file. Yup, it's being properly loaded. We just tried it on this laptop, but the laptop isn't damaged at all. I gotta applaud how well this laptop is manufactured. Next up is this custom PC. I'm sure shocks are always a concern when you're building your own PC. So, to see if static electricity actually has a huge impact, we'll apply the discharge gun at the RAM memory today and check whether or not the PC will still function properly. The static electricity test from earlier has a standardized method. We'll test it like this today, but this is not the standardized method. For testing static electricity on components like this, there is a standard way, so please follow that method. What I want to do is discharge the memory card with the discharge gun first. Then I'll insert it back into the motherboard and see how it affects. In terms of the voltage level, we can adjust it however we want, but we'll go with the 30 kilovolts at the max. It's discharging. I bet this will impact the memory quite a bit. Let's do another round. In daily life, you will never experience shocks of this strength. Now let's put it back in and see what happens. We'll insert the memory that was just discharged back into the PC and check to see whether or not it still works. I don't think it's going to be useful anymore considering the strength of the discharge. It seems to not move on from here. Has it been broken now? I can turn the power on, but the screen will no longer turn on. So I believe the memory is completely broken from the discharge. Yup, it's broken. In the last experiment, we discharged at the memory alone and it completely broke. This shows how careful we have to be when handling memory cards. Next, I will keep the memory inserted in the motherboard. And then we will apply the discharge gun at it to see what kind of reactions we will get to see. Oh? Although it hasn't been shocked yet, the screen has decided to restart itself. Perhaps the strong magnetic field affected the parts and caused it to malfunction. This was actually unexpected. Previously, we set it at 30 kilovolts. But apparently this is too strong and has caused the PC to shut down every time that it's discharged. 30 kilovolts was probably a little too strong to be honest, so we'll set it back to the suggested voltage level of 8 kilovolts. Then we'll see what happens with that. First we'll start off with 4 kilovolts. The screen has shut down again. The screen is shut down, but the CPU and the fan are still moving. Actually, let me restart the PC. I just restarted and this pops up on the screen, which means the PC is still up and alive. RAM memory is functioning properly too, so I just discharged the memory at 8 kilovolts, which is quite strong. But as you can see, the screen is working, meaning the memory card was not damaged by it. I wasn't expecting this at all, to tell you the truth. I originally thought that this would break much more easily. This makes me wonder, perhaps static electricity from contact with a human isn't strong enough to break anything. Before moving on, let me try 30 kilovolts once again, and see if it does break, or it doesn't break. Okay, let's restart this now. It does not turn back on. Yep, it's broken. Take a look at this right here. The fan starts moving when I press the power button, but it stops right after. If I discharge when memory is inserted, we can't tell which part of the PC was actually affected. So let's remove the memory and restart the PC again. It seems to be broken without the memory as well. Like I said, the fan moves for a second, but then stops right after. The memory card is definitely broken, but also, the discharge transferred through memory to the other parts. For that, the circuit around the memory is definitely broken, and even the CPU might be broken as well. In daily life, it's very unlikely that you'll ever experience static electricity that is as strong as 30 kilovolts. That being said, there shouldn't be too much to worry about regarding shocks. In fact, we tried with 8 kilovolts and the PC was still working after that. We just needed to restart it. Our second experiment was discharging this PC memory card. From the result, it seems that static electricity from human contact isn't strong enough to break it, but in the worst case scenario, it is possible. But at least we learned today that if we discharge at 30 kilovolts into a device like this, it will most likely always break from static electricity. To be honest, we literally discharged right at the PC this time, so it was somewhat expected that it was going to break. But for the laptop, because it is covered with a strong material, even 30 kilovolts didn't affect it at all. That makes me think that any electronic device with a cover like this is probably pretty strong against static electricity. I hope this gave you a good understanding of that. For our next test, we'll use this smartphone. It's Apple's iPhone. I'm not sure what model it is, but it's probably something like the iPhone 5. It's normally the case that any portable device like this is usually strong against shocks. I hope this test will clarify that as well. Do you see the video playing? As you can see, the video is playing perfectly fine. I'm amazed. I'm using the iPhone after discharge right now, and it's very clear that there is no problem at all. It's working just fine. Alright, so we just discharged this smartphone. The video was playing while it was being discharged, but there was absolutely no issue with playback either. Just as I'd heard, these portable devices are strong against static electricity overall. Alright, we can move on. Next up is the SD card and the USB. We'll check the data inside after the experiment. Let's do it. I can't really see the discharge. Can you see it? We'll discharge the USB as well. Now that we're done with discharge, let's check the data inside. We'll start with the SD card. The drive itself is being detected, but I can't open it at all when I click on it in the File Explorer. It seems to be completely broken. Well, since the SD card was broken, let's check the USB. Perhaps it's broken? Oh, wait, it was detected successfully. Let's see if the file inside is still safe. The video file inside the USB is perfectly fine, but how about this image file? Okay, there is no issue with the image file either. While the SD card was broken, the USB was completely fine. The difference between the two is the SD card's terminal isn't covered at all, whereas for the USB, the terminal is somewhat covered with this metal case-like part. It's possible that for the USB, the actual terminal wasn't discharged. Instead, it might have discharged the outer metal cover. I believe that this is why the USB wasn't affected at all when the SD card was hugely impacted by the discharge. Like I said before, the terminal for the SD card has no cover at all, which means it was discharged directly. I believe that caused the damage to the memory cell of the SD card. Okay, so this is a slight spin-off, but I want to test with this watch. Let's see, this is Casio's watch. It's a pretty high quality watch for its listed price. If I'm correct, analog watches wouldn't be affected by the discharge. That's why I brought this digital watch to see what kind of effects it will have. If you look, the screen panel is quite a mess when it's discharged. When discharge starts, the screen is not readable anymore. In general, static electricity is apparent where the metal parts are sticking out, like here. Well, it does discharge like that to the metal parts, but it doesn't affect the functionality of the watch. Right? Nothing has changed. However, when I bring the discharge gun right where the screen is, the screen starts to look as if it's buggy. Nonetheless, the displayed time is still accurate. It was all buggy after the screen was discharged, but even after all of that, the watch works just fine. Let's go to the conclusion now. On this side, we've got the laptop, the smartphone, the watch, and the USB. I've grouped them together because they were not affected at all. I believe for these products, the frame almost acts like a shield, protecting against static electricity and preventing it from impacting the IC chip or other parts on the inside. It's also possible that it is well made to protect them from static electricity in general. The same goes for the digital watch. When discharged right at the screen went all buggy, but otherwise there was no problem. On the other hand, these are all the devices that broke. This includes the SD card, the RAM memory right here, and the motherboard for this PC. In the end, this broke as well. When there is no cover protecting them, the shock can damage them, making it harder to protect them. For this memory, it literally broke after 1 second into the test. We also tried on the PC with the RAM inserted, and that broke the PC. The same goes for the SD card. It discharged right at the terminal on the back of the SD. The PC still detected the SD card when inserted, but the data could not be retrieved or opened at all. With the motherboard right here, it pretty much breaks as a whole and as each component as well. Once again, the sponsor for today's video is Nihon Denki. Nihon Denki is a company that handles the various kinds of measuring and testing devices. They have 47 offices throughout Japan. Not only that, but they have 50 offices around the world, with most of them being in Asia. If you ever want any consultations about either measuring or testing devices, Nihon Denki is the right place to ask. You can find out more about them in the description below. Okay, so this is it. Thank you for watching. That's the other side. Oops, you right, it's this one. So this time, we'll first insert the memory into the PC and this is the shielded room. It's basically a room with all sides covered in metal. For instance, this wall is completely covered with some metallic material. Take a look at this floor too. As you can see, it's coated with metal as well. Even the door right here is fully metallic. When you fully close it, there will be no data for your phone. Let's see if that's true. Let's see. Yep, there is no data in here. Take a look. The X on the top left indicates that there is no data. This is the strength of 30 kilovolts. On a side note, I kinda want to try this on myself, but do you know what happens if you get shocked with 30 kilovolts? I've never tried it, but apparently you can feel pain through your shoulders even. Oh, really? You'll feel really tired for the whole day after that. I see. Okay, cool. So I shouldn't do it today. Okay, here it is. Let's actually test it on a human body too. I think we should start off for something lower, like 400 volts. I don't feel anything so far. 400 volts is too low to feel anything. Let's turn it up gradually. We'll make it a few times stronger now. Ooh, I feel it. I definitely felt it. I get like a small spasm. It's 4 kilovolts, but it's not like the normal shocks that you get. It almost feels like your muscle is forcibly moved. It's not really anything like the shocks that you would get from something like touching the doorknob in the middle of winter. Those shocks go through the skin or just the surface. But this one feels more like it's running through your entire body. I'm going to turn it up to 8 kilovolts. I assume that there's going to be quite a shock for this one. Whoa, this is strong. At 4 kilovolts, the shock came to right about the second joint on my finger. With 8 kilovolts, I could feel it in my entire palm. That's how strong it got. It can go up to 30 kilovolts, but I don't think my body can handle that, so unfortunately, not today.